When we talk about spherical mirrors, there's basically two types. There's the convex, or I'm sorry, let's start with concave. There's the concave mirror, and that bulges in when you look at it, and it magnifies. So a concave would look like this direction with the rays coming into the bulge. Then we have the convex mirror, and that bulges out and it makes images smaller, so it demagnifies. And the convex looks like it's bulging out, and the light rays come from the side to hit the bulging side out. Now, to be in focus, for you to be able to see the image, the rays must meet at one point. And there's a inaccuracy with spherical mirrors that we have to account for. And let's see why. Now, if I have a parabola, then all of the rays coming in parallel to this parabola will all bounce off or reflect in such a way that they will all meet at a specific point called the focus. This is actually how a parabola is defined. So here, if you had these rays on the opposite side, then they're going to go up through the focus. Like so. So parabolas are really good at it, but if you have spherical, it's not a parabola, you notice that they don't meet in the same location or the same spot. So how do we get around this to be able to use spherical mirrors? Well, the trick is to use the very tip or the very end of the mirror, and in this case, let's say we're using a formula for the parabola, x squared plus bx plus c. In this small area, bx plus c becomes very small or goes to 0, and I'm just left with the x squared part, and so it becomes or looks almost spherical because x squared is a term in the spherical function. And so in doing that, then I can get, for very small mirrors, I can get the rays to go to a point in this focal point where the rays converge. But this center point has to be extremely long. This is the radius of the sphere, a spherical lens. This has to be very large compared to the curvature of the mirror. And the focus is going to be equal to the radius divided by 2. So it's very easy to calculate the focus when we're talking about spherical mirrors.